Okay, so now it's time for the next talk. Aleksandr Sulimov here will tell us about Repid, the new job scheduler with Asyncio in mind.
Hello, everyone. Thanks. Today I would like to give you a talk about Repid. Let's start with a quick introduction. My name is Aleksandr Sulimov, as presented. You can also call me Alex for short, and find @Alexu on various platforms. I'm Python backend developer. I work with cooperation with global travel tech company Kiwi.com. And here are a few keynotes about me. I started to learn Python when version 3.4 was the latest one, so I recently checked it's around 8 years now. I did a lot of hardware, embedded software engineering after that. And eventually I came back to Python when Asyncio started to gain more popularity, to work on it, basically. So I have a quick question for you, for the audience. How many of you do actually use queues in your application? Please raise hands. So, some people. Don't worry, if you don't use them yet, please treat this talk as an encouragement to begin practicing it and queue up your questions, pun intended. Let's go. So, let's look at existing solutions. So, here we have simple salary application. And as you can see, it's quite easy. You declare your application, you declare your function with app.task. And that's basically it. But then, of course, this example is far from real world. And you can imagine another function which does some actual job. It can query some website. You can perform some cacheable operation. You can store something to database. And there is a common thing between those all operations. Does my process really have to wait for those operations to compute? And in fact, it doesn't, because all those operations can be asynchronized. They're all I/O bounded. So Asyncio comes to the rescue, and we will modify our function. And first of all, we will start by prefixing our function with async keyword. Then we will replace our I/O-bounded operations with available alternatives. For this particular example, we will use HTTPX instead of requests. We will imagine that our cacheable operation is performing, for example, cache lookup asynchronously or something like that. And our database driver was replaced with an async alternative one. However, there is a catch. The catch is that neither salary nor dramatic, which are the two most commonly used libraries, support Asyncio natively. Well, that's where we introduce Repid. Repid is a task processing library with Asyncio being the idea of Asyncio being the first-class citizen. Few key points about the library. I've started it on October 21st, 2021, so it's more than 2 years in development. It supports RabbitMQ and Redis as the backends currently. Possibility to add external backends as well is there. Naming comes from Redis RapidQ, because initially it was just Redis Q, but now it's multi-backend paradigm. It supports Python 3.8 up to Python 3.12, which is in beta now. It's 100% non-compiled Python. It allows you for easy integrations with everything in Python world, even such things as Pyodite, which will allow you to run it on the web, and we will come back to it in a second. It has 100% coverage. It is battle tested in production. It doesn't require you to install any additional dependencies, and it's fully typed, so you will get editor support and perfect MyPy support as well. So with that in mind, let's come back to our example with Asyncio. now we can use Repid, and we will replace Celery. And we will start by creating a Repid router, and then we will decorate our function with router detector. And that's basically it. Now we need to focus on how to enqueue a message in our application and how to run a consumer for it. But first of all, I would like you to encourage and try on your phones this QR code. It will take you to Repid documentation and, to be exact, to Playground. I've mentioned already Pyodite, so it's super cool and allows you to run on any platform which runs a browser Python code, and including Repid. So there you can see a simple Repid app which you can run. There is a click me button or something, like run it button, and you can also edit it if you want. Yeah. With that in mind, let's see quickly what is roughly the structure of a Repid application. So we have initialization consumer part, producer part, and the part which runs the consumer. That's basically it. It's under 30 lines of code, 4 stages. Let's look deeper into it. So here we have the initialization and consumer part. As you can see, we are creating a Repid app with in-memory message broker. So it doesn't need to use any RabbitMQ or Redis spin up something. Then we create our router, we decorate our function with it. We have our function with some async IO seemingly emulation, like we use Asyncio sleep to emulate Asyncio bound network. And that's basically it. To query this function, enqueue a message, we use this app.magic thingy, which will allow us to inject our connection to in-memory message broker. It will also do it the same way for your other brokers like RabbitMQ and Redis. And we create our job. The name of the job has to match the name of our function, so we can see our actor, Sleepy Python Hello, is named this way. So we can actually then separate this job and make it in some other separate repository even, because it doesn't have to be tightly coupled. We declare our queue, we enqueue our message, then we create a worker. For the worker, we will specify that the worker accepts the router. So from here, line 6, we will take our router and specify it in the worker. Then worker will be aware of our actor. And we say that messages limit is equals 1, just so we haven't queued only one message. We want to exit after we have processed the message. And we do it with worker run. And we have a very simple construct with asyncio.run to actually run our main function. So it's quite simplistic. Let's take a look at what also is present in Repid, but it doesn't distinguish it from other libraries though. So we have auto retries with the ability to specify custom retry policies. So imagine if your actor fails, you still will be able to specify how many retries you should have and how the next retry time should be calculated. We have prioritization, so you are able to tell your message broker how high of a priority your job is. We have deferred task scheduling. You're able to schedule executions at a specific time deferred by some period of time. Is everyone okay? Yeah. So for example, you're able to say, execute my job every 10 days or so. Or you are able also to specify cron. So for example, let's execute our actor every Monday at 3 o'clock. There is a support for storing arguments and results in separate storages. So for example, you can use Redis for that. You will be able to store your some huge blob of data in Redis, and when your actor will be executed, it will just query the Redis storage automatically for you and insert it in your actor. so that doesn't have to go inside of your message, because message brokers usually are not optimized for huge amounts of data. And there is an in-memory broker support for testing purposes, as I've shown you already. So let's take a look at what is present in Repid and distinguish it from other libraries. So first of all, Repid is transactional by design. The meaning is that if your worker dies unexpectedly, you will still get the message processed. So let's take a look at this diagram. We have some message broker and have two workers. So imagine message broker decided to give arrow message to one of the workers, and then workers started the processing, and suddenly the worker has died. The message broker will go, I haven't received any acknowledging for this message, and it will reschedule it to another worker. Another worker will pick it up, start processing it. It will acknowledge it eventually, and the message will get processed only then. Another cool feature of Repid is the proper routing. So if you have like event-driven architecture, there can be a situation when you would like some messages to be queued up in one queue, but actually to process different topics. So therefore, you would be able to also have like different rounds on the same queue. And we can also use it to do versioning, which is very cool. So let's imagine a situation where you have like some amount of workers. Here I have 3, for example, and we have updated one of them already to version 2, and 2 of them are still at version 1. So what will happen is we scheduled a message for version 2 worker. Our queue will go and give the version 2 message to the first worker, like round robin, for example. And the first worker will say, nah, I want to reject this message. It's not for me. I don't have any version 2 actor on me. And message broker will pass this message to the second worker. Second worker will go, no, I also don't have version 2 on me. And then eventually the message will go to the last worker, which is version 2, and will be processed there. In reality, how you would do this, this is the same example. So we have this sleepy Python hello actor, and let's say we want to version it. We can simply add version 2 in the name of the actor, which will rename the topic. Or another way, we can specify name override directly on the actor, which will also override the name of the topic, meaning that when we schedule the job, it will be only processed by the right actor because there is a routing on the application level. Let's look at performance. So first of all, a short disclaimer, you should never use as the one and only decision-making performance graphs or anything like that. It's important to note that benchmarking is a complex process, results of which can be affected by various factors. And I highly advise everyone to create their own benchmarks for their specific situation. And with all of that in mind, let's go to the graphs. So here you can see 4 different libraries compared by amount of messages processed in a second. I'm using IO-bounded job, where your application will sleep for a second to imitate IO operation, and then it will increment a field in Redis. So it's very simple, yet it will show an example for you where you have some IO-bounded operation, and it doesn't depend on external factors. You can also find the exact benchmarks in the Repid GitHub repo. So here Repid comes first, but the difference is not that big actually, but there is a catch. I have enabled green threads for Celery and Dramatic. For those who don't know, green threads are lightweight concurrent programming units that allow you for non-blocking execution and cooperative multitasking within a single thread. It's similar to Asyncio, but problem with green threads in Python, it's essentially monkey patching. So usage of green threads in production is highly discouraged. And if we disable green threads for dramatic and celery, this is how the graph will look like. So as you can see, Repid is approximately 15 times faster than its nearest competitor, Arc, and approximately 700 times faster than Celery. Another cool feature of Repid is identic validation, which is built in. So you can declare your input and output models for reactors in Repid, and Repid will ensure correctness of your data with the help of identic. Both version 2 and version 1 are supported, so you can try it in any case. You can do simple types, as you here can see with user ID. You can do some generics, as like you here see with actions. It is list of strings. You can do some identic models directly. Identic models can also be nested and everything. It will work just fine. You can also specify your return model validation. So for example, here I'm returning dictionary, which contains actions, but my return model is not containing any actions field. So therefore, identic, when validating this, will remove actions and will only return user ID. It can be very beneficial for security, for example, so that you know that you are not accidentally returning something wrong. Sorry. Repid also comes with a simple HTTP health check server. So, for example, if you're using some orchestrator like Kubernetes or something similar, it usually needs to somehow understand that your application is healthy and running. To enable health check server in Repid, it's very easy. So here we have the example which I showed you earlier about the producer and worker part. We don't need producer part here, so we'll just omit it. And let's look deeply into the worker. So as I've said, enabling it's very easy. You just specify run health check server equals true. And that's basically it. When you will run your worker, like await worker.run, it will run also Asyncio task for you with health check server. So as long as your worker is running, your health check server is running, and your orchestrator is aware of healthiness of your application. You can also override settings quite simply, like you can specify the port, the endpoint name, etc., etc. Another feature, if you want to extend the functionality of the framework itself, you can use middlewares. So to create a middleware, you simply need to specify to which signal you would like to subscribe. You can do it either by class approach, where you will have this method, like here I have after actor run, or you can do it by functional approach. Also, it will be just global function after actor run. And here we have example when we would like to capture our exceptions with Sentry. Yeah, that's quite simple. Of course, it's all documented, so you can find details about those signals and which keywords and which types are there on the documentation. And this is an example, for example, an example of logging your not acknowledged messages. So, for example, your actor has failed to process something, and your message will eventually, after some retries, be put in dead letter queue. So we probably want to know about it, and maybe we have some custom logging in place, and we can ensure that we will execute this custom logging logic with middlewares. So what's for the future? You can check on this QR code Repid repo and submit your enhancement proposals, of course, in the issues. Feel free to do that, as well as any bug reports. The future is bright. We want to add support for generating a sync API schema. We want workers to be able to communicate with each other to support, for example, task cancellation and some on-the-fly changes to already enqueued messages. maybe then we will be able to also create some dashboards and everything like that. And ideally, we would also add auto routes generator for FastAPI, so that you won't have to specify precisely, like, I want this route to query that job and everything. It will be just automatically generated for you, as well as, for example, if you want to retrieve result of your task, it will be also generated. And while there in the repo, you can leave a star. So, as well as Milan said already, and if you're not convinced yet, and want to build Trello technology with us in Kiwi, we have an open Python role developer. You can check it out there. And that's it for me. Let's take us to the Q&A.
Thank you very much. Yeah, we have some questions and some questions coming up still. Okay, so first question, does it work with Kafka?
So short answer is not yet. It's a bit complicated to integrate it with Kafka, because Kafka Asyncio libraries in Python are a bit complicated, let's put it this way. But there is an enhancement proposal for it to be integrated with Kafka, and I think we will implement it someday.
Thank you. Next question, can I have also a non-async actor?
Yeah, it's a very great question. So yes, you can. Moreover, as our previous speaker has mentioned, you probably would like to execute it in a thread or maybe in a process if it's not IO bounded but CPU bounded work. And you can do both with Repid. You can specify, I believe the flag is called run in executor. So in your actor settings, you can specify this flag, and it will determine if your synchronous function will be running in thread executor or in process executor.
Thank you. Does it use some kind of schema registry for message versions?
So it does not yet. There is a way for you to specify how you want your message to look like. So quick answer would be that you are able to inject whatever message schema you would like to have there by using, like you can implement it. There is like a config class, and you can inject your own data classes with a schema of your message there. It's not yet documented, though it will be, and it's coming very shortly, the documentation for it, but it's already there.
Thank you. And does Repid support database as a broker?
No, but you can implement any broker. The interface is very simple. You just need to implement a couple of functions, such as like acknowledge, not acknowledge, reject the message, and then you will be able to use dependency injection pattern to actually run your message broker. So it's as simple as inheriting from connection ABC or something like that, it's called there, and implementing your own message broker. It's not that hard, and I highly encourage you to do that if you want some weird solution.
Thank you. Is it possible to have periodic tasks scheduled with Repid, for example, execute on every Monday at 8 a.m.?
Yeah, sure. You can do periodic tasks as cron. So here's the example. When you want it every Monday on 8, that's like a beautiful example for cron. And you can also do periodic tasks with some, let's say, like every hour or so, yeah, or like every 15 minutes. There is also a possibility to do deferred by tasks. It's called like that. So the way you do it, you will specify those arguments inside of your job definition.
Thank you. Does it support queue browsing, meaning checking what is in the queue without consuming it?
No, not yet, and that's where our future idea for making workers communicate with each other comes in, because then you would be able to do this. Problem is, many message queue brokers do not support this feature as a whole, like no matter what you are doing actually. So it's quite problematic to integrate it, especially while having this very simplistic interface for others to implement their own brokers. So that's why we want this context-aware workers to be available in Repid, so that it will be available for everyone. So it's not there yet, but it's on our shortlist for implementation.
Okay, thank you very much. Is it possible to have only unique messages in the queue?
Yes, it is. So there is a parameter called ID, and if you will specify it, by default, it's automatically generated like UUID4. It will always be unique. But if you want your job to be unique and your message broker does support it, for example, our Redis implementation does support it, you can definitely declare this ID, and your message broker will ensure that the job is unique.
Thank you. In what cases is using Celery or Repid better than using Asyncio?
So integrating Asyncio with Celery is possible. However, it's quite complicated and requires a lot of boilerplate around it. And even after that, your communication with the message broker will still be synchronous, and only the actual tasks which you're processing inside of Celery will be asynchronous. So that's the main use case, because still you're communicating with the message broker over some network, usually, at least. So for example, like you have some TCP socket or something to communicate with your message broker. And it will take advantage of it as well by being asynchronous. Well, Celery will not support that, because it will require them a complete rewrite of the application, which is not possible, of course. And Repid supports it out of the box, so that's the main difference in case of comparison in Asyncio. Yeah.
Okay, thank you. What about task results? Are they stored in the database?
So when you are selecting your connection, there is such an abstraction in Repid as connection. Let me show you. Here in initialization, you can see we are creating app and we have connection, and we have in-memory message broker. So in that connection, you can also specify arguments broker and result broker. Those will also have like very simple interface, so you can implement whatever. For example, Redis is already there, so you can store your results to the Redis, and then on your job there is also a synchronous function called result. And if you call this function, you will get a result of your actor, if there were any, and if your actor was completed already. So you have to ensure that you have completed it, but otherwise, yes. So it's supported to store results wherever you want.
Okay, so yeah, like we're out of questions. Thank you very much.